In this video, we're going to be taking a look at 3.2, multiplication of rational numbers. Now, if you haven't watched the 3.1 video, please go back and watch that one. It really explains the why is it when we multiply two negatives we get a positive, why when we multiply a negative by a positive we get a negative. It helps explain the why to all of that using the distance is equal to rate times time equation. So this is a video for after 3.1. We're looking at more patterns. Again, understanding patterns and how numbers work together is extremely important to get the big picture. And so that's kind of what we're looking for here. And in number one, it says, what do the examples in each group below have in common? Now, there's a lot of different answers here, but if you want to, just go ahead and pause the video and see, write down your answers. What are some different ways or what things that these have in common? Pause it, answer that question, and come back. All right. So most commonly, students are going to see the fact that the rows are more in common, like these rows. Right? You have that row, then you have this row with the 5.1 times 1, and then the last row with the 3 times negative 4.5. And you notice the only things that are different on those rows are the fact that in group 1 they're all positive, group 2 there's 1 negative, and group 3 there's 2 negatives. Okay? And then go ahead and find the products. If you haven't, pause the video and find the products in each of the groups. So copy down group 1, group 2, group 3, and maybe when you're copying it down, go ahead and when you're doing these, just create another column here for each one of these so that you can write in the answers. Pause the video and then come back once you're done doing that. And so now we should see in the first row, you have 12, negative 12, and positive 12. Second one, 5.1, negative 5.1, 5.1. Third row, 13.5, negative 13.5, and 13.5, right? And so now write and solve two additional problems for each group. Again, that can be anything, whatever it is. They're both positive there, one negative there, and then both negatives here. And now we're going to start looking at the idea of whether multiplication is commutative. Remember, commutative, the root word, the prefix. As a math teacher, I don't know if I'm using that correctly. But anyway, there's that commute in there, and that just means to go back and forth. If you're commuting to work, you go back and forth. So in mathematics, in multiplication in this case, it means, hey, these numbers can move back and forth, meaning I can take 2 times 3, and that's the same as 2 times or 3 times 2. And it's the same as if they're multiplying negatives. It doesn't matter. As long as everything is being multiplied, multiplication is commutative, because here you get 6, here you get 6, here you get negative 6 on both sides. Okay, so yes, it is. And then go ahead and write down in your own words what makes it commutative. Okay, jumping down to part C. Now we're looking for algorithms. An algorithm is just a certain rule. Like, for example, the first one, multiplying two positive rational integers. So you're taking this positive times this positive. Well, the algorithm would say, hey, when you multiply two positives, your product is always a positive. So you would write out the words. When multiplying two positives, your product is always positive. We can look up here. Like group 1, these are all positives. Our product was always positive. Okay, so we're going to write those words out for that algorithm number. And go ahead and do 2 and 3. Pause the video, do those, and then come back. Okay, so hopefully you did these already on your own. Again, we're writing them out in words because mathematics is a language that we have to understand to speak it and to write it well. So 2 says, describe an algorithm for multiplying a positive rational number and a negative rational number. So that would be like column 2 up here, right here, group 2. One of these was positive, one was negative, and when we multiplied those, our product was always negative. And when you're writing these out, use the words that I'm using. When I say the word product, that just means the outcome when you multiply two numbers or more, two or more numbers together. That's the product. The product of 2 and 3 is 6. The product of 2 and -3 is -6. So as you're writing these algorithms, use these same words in your sentences that I'm using as I describe it. And in 3, describe an algorithm for multiplying negative rational number and a negative rational number. So that would be like up here, right here. What? No, sorry, it's right here. Negative and a negative is that middle one. And a negative is group 3. So your product of two negative integers, or rational numbers in this case, because we have the fractions and decimals, the product of two rational numbers that are both negative is always positive. Always going to be positive. All right, so make sure you have those written down. You can write them in words. Absolutely write them in words. Also, you can do pictures. Like I told you many times, I'm a visual learner. So, this is what my algorithm would look like in my head. Two positives. When I multiply two positives, my product is a positive. Here, it's a positive times a negative. My product is always a negative. A negative times a negative. My product is always a positive. All right, so visually in my head, this is what I see. Write the words out as well. That's hugely important. And let's jump on to D. On part 1, all you're doing is predicting. You're not finding the answer on part 1. You're predicting, is my answer going to be a positive? Is my answer going to be a negative? Right, so really, like on part A, the first one is a positive. This 7 is a positive times a negative times another negative. Now, what is my product going to be? Is my product going to be a positive, or is my product going to be a negative? Pause the video, answer part 1, and then come back. Okay, so for part A, you would see, for part A, when you multiply a positive with two negatives, well, listen, up here, when I multiply two negatives, I get a positive. So these two are going to come together to get a positive, and I still have this positive up here. So multiplying one positive and two negatives is the same product as multiplying two positives, which up here I know is going to be a positive. So on part A, we're going to have a positive product. On part B, you have 1, 2, 3 negatives being multiplied together. And so for that one, it's going to look like this. A negative times a negative times a negative. Now remember, a negative times a negative, it's kind of a smiley face there. A negative times a negative is a positive. And then you have this negative down here, but a positive times a negative is a negative. So on B, our answer is going to be a negative value. And then on C, you notice in there, there's only one negative in there. And that means our product is going to be a negative product. All right? And then part 2 says, explain how you use what you know about multiplying two rational numbers to multiply three rational numbers. Oh, wait. I guess it does say, then find the product. All right, so we can go through and find the product, and we can ignore the signs. The whole point of question 2 is that saying, hey, we don't have to worry about the signs anymore. Right? We can just take 7 times 8 times 3 because I know my final answer is going to be a positive. So we can ignore the signs, just multiply these together, and then add in the sign at the end. Also, coming back up here, understanding that math is commutative, we can multiply these in any order that we want. If we wanted to take 7 times 3 first, we could do that. So this is the same as 21 times 8. And then you can multiply those if you wanted to do that. Or you could go old school, right? And you know that 21 is the same as 20 plus 1. So change that to 20 plus 1. 8 times 20, so 8 times 2 is 16, so 8 times 20 is 160. 8 times 1 is 8, so 160 plus 8 is 168. So instead of using the humdrum algorithm, you can think of it like this, and this is what they're teaching in the lower levels. Just, not the algorithm. You're not really understanding what's going on with the numbers with the algorithm. Here you understand more of the properties of the numbers that you're working with. Okay, and go ahead, you can find the rest of those on your own if you haven't already. Pause the video and go ahead and find those. So now let's take a look at B. I did it with black ink there. Again, you can ignore the fact that it has negatives because since there's 3 of them, we know that our answer is going to be negative. So you have 12 times 5 times 4. Again, you can multiply these in any order. So what I did is I multiplied those together because I know that that's 20. And then I split 12 up into 10 plus 2. And then when I distribute this 20 in right here, you get 10 times 20. I can do in my head, that's 200. 2 times 20, that's 40. Add 240, that is 240. But then finally, we know that our answer was negative, and so we have negative 240. Part C, you should have gotten -1 because when you write these things out, the 2's will cancel and the numerator and denominator will cancel to 1's. The 3's in the numerator and denominator will cancel to 1's. And so everything multiplies together to give you just 1. And since we know that since there's only 1 negative, our answer is going to be -1. We already answered number 2. So go ahead, take the time to answer that in your notes, and then move on to part E. Now with part E, the first part is predict, okay, if it's going to be a positive or negative. And you notice on A through E, this looks like, I got to do 1, 2, 3, 4, 5 different problems. But nope, it's all 2 times 3 times 4 times 5, every single one of them, okay? The only difference is sometimes there's negatives on those numbers, sometimes they're positive, they mix it up. Okay, so part 1 is just going through, is your answer going to be positive or negative? Explain your reasoning. So pause the video, answer that for each one. As you're doing your notes, again, notes are supposed to be useful. So when you take notes, they need to be taken in a way where you can look back at them and find them useful. So please rewrite A through E in your notes and then answer your questions from there. So rewrite all of this in your notes and then come back and answer those questions if your product's going to be positive or negative, and then come back to the video. Okay, so in part A, you should have that this is going to be a positive product because all of these numbers are positive. Part B, you should have that this is a negative because there is 1 negative in there. Part C, this is going to be positive because there are 2 negatives in there. 2 negatives multiplied to give you a positive. And then D, this is going to be negative because these 2 negatives right here are going to cancel each other out, or it doesn't have to be those 2. It can be any of the 2. When you multiply these, those are going to cancel each other out. You have 1 negative, so your answer is going to be negative. In part E, these negatives cancel each other out, these cancel each other out, so it's going to be just positive. Now part 2 says find the product, check whether your predictions were correct. And then 3, explain how to determine whether a product will be positive or negative. So we've already somewhat answered these up here, but rewriting it is not going to hurt you. So just kind of rewrite your findings and your understandings of all of this to just understand it and to remember it that much more. So go ahead and answer number 2 and 3 and then come back to the video. Okay, so when you take 2 times 3 times 4 times 5 using the commutative property, you can multiply them in any order. So I just take 2 times 3 and then 4 times 5, took 6 times 20, got 120. Now for each one of these, the product's going to be the same. It's not going to change. The negative doesn't change the absolute value of this number right here. Okay, sometimes it'll be positive, sometimes it'll be negative. Like part A, our answer was 120. Let me do this in red. 120. This is negative 120. This is positive 120. This is negative 120 and positive 120. Okay, and then were your predictions correct? I hope they were. And then whatever your explanation for that would be. Different students are going to have different explanations. There's no one perfect explanation. Just as long as it makes sense and is correct, then it's fine. This is my video for 3.2, multiplication of rational numbers.